So here in the app folder, let's add a new folder called utility. And in this folder, let's add a new file called cache.js. Then here we're going to import async storage from React Native. Then we're going to define a function called store, which takes a key and a value. Now, before I forget, let's export a default object with the store method. Then here we're going to call async storage.setItem. We pass the key. Now we can optionally add a prefix like cache. It's just my personal preference. You don't have to do this. So we don't want to hard code this here. We want to store it in a constant that we can reuse in multiple places in our code. So prefix equals cache, and then we can use it right here. So we pass the key, and then for the value, first we have to serialize it as a string. So we call json.stringify. With this, we don't have to remember to call this method every time we want to store something in the cache. So that is one of the benefits of this layer. This method returns a promise, so we have to await it, and then mark this function as async. Now, because we're using await here, we should wrap this code inside a try-catch block. So let's add that real quick. Good. So if something goes wrong, for now, we're going to log something on the console. Okay. As I told you in the last video, our cache layer should also apply a timestamp to each item. With this, we can determine if an item is expired or not. So instead of storing the value directly, let's define an object called item. This object is going to have two properties. One is the value that gets passed from the outside, and the other is a timestamp. We can set that to date.now. Now, let's add it over here. Good. So our store function is ready. Now let's implement the get function. So get is a function that takes a key. Now let's export this from this module. So in this function, we're going to call async storage.getItem. We pass the prefix plus the key. We get a promise, so we await it to get the stored value. Now let's make this function async. So this value is a string. Now we need to parse it as a JSON object. So json.parse. With this, we get the actual item. That is the item we created earlier. So this object over here. Now here we should wrap this code inside a try-catch block. So try-catch, good. Let's move this code up here. And in the catch block, let's log the error on the console. Okay. So we get the item. Now here we have a few scenarios. One scenario is where the item doesn't exist. So if we don't have this item, we're going to return null. The second scenario is where the item exists, but it's expired. To calculate expiry, I'm going to use moment.js. It's a very popular library for working with datetime objects. You're probably familiar with it, and you're probably going to say, hey, Mosh, but there are more lightweight alternatives. I'm aware of that, but I want to deliberately use moment.js here so we can talk about optimization in the future. So let's install Moment. Good. Now, here on the top, let's import Moment from Moment. Now, to see if the item is expired or not, first we get the current date time. So now equals moment of date.now. We should create a second moment object for the timestamp of this item. So let's call that stored time. We set it to moment. And here we pass item.timestamp. Next, we calculate the difference. So diff equals now.diff. Here we pass stored time. And as the unit, we specify minutes. Now let's make an assumption. If the item was stored more than 5 minutes ago, we can say it's expired. So let's rename this to isExpired and turn this to a Boolean expression. Now we don't want to hard code this value here. We should define it as a constant on the top. So let's call that expiry in minutes. Now potentially in the future, we can store this in a configuration file, but let's not worry about it at this stage. So if the item is expired, then we should return null. Now here we can also clean up the cache. So we call async storage dot remove item and pass prefix plus key. This returns a promise, so we should await it. Now here we are violating an important principle in programming called command query separation, or CQS principle. This principle says that our functions or methods should either be commands or queries, but not both. A command function is a function that changes the state of the system. A query function is a function that returns the state of the system. In this case, our get function is a query function because with this we're querying data. So in the middle of this function, we should not change the state of the system. This is a violation of the command query principle. But in this case, it's okay to violate this principle. It's not the end of the world. We are doing this for a good reason. We don't want to store too much data in the async storage. So we're consciously breaking the rules. So we're done with the second scenario. Now, if we get to this point, that means we have an item that is not expired. So we're going to return item.value. We're almost done. The last thing I want to do here is to extract this logic and put it somewhere else, because this is violating the single responsibility principle. Because our get function now has two responsibilities. One responsibility is getting an item from the cache. The other responsibility is detecting if the item is expired or not. These are two separate responsibilities. Our functions or methods should have a single responsibility. So I want to move this logic somewhere else. Let's define another function called isExpired. It takes an item. Now, let's grab these three lines and move them right here. So we give this function an item, and it tells us if the item is expired or not. Okay? So at the end, we can simply return the value of this expression. Now, let's call this function. So if this item is expired, then we're going to remove it from the cache and return null. So we're done with our cache layer. Next, we're going to use it in our API layer.